Good morning, everybody, and welcome to August Moti-Vitality member exclusive webinar. I'm absolutely thrilled to have all of you here. Um, and um, so, you know what I just realized, and I'm embarrassed, and I'm gonna have to forward a copy of the recording. There was a guy I said I was gonna forward this email to, and I totally forgot. So that's what the pause was for. I was looking to see if he was on, and he's not. But that's because I totally spaced out on forwarding the email to him. So I'm not gonna do that right now, but I will send him a copy of the recording, and when he comes on and listens, he'll know who I'm talking about, and hopefully accept my apology. So anyway, lesson to those of you that are on here: if I tell you I'm going to do something and you haven't gotten it, please don't hesitate to call me and say, "Hey, you said you were going to do this," because it's possible that I forgot. So anyway, today we're going to be talking about common questions customers ask about water, and everybody is. A lot of you are unmuted right now, which is fine. I think I am going to go and mute everybody, though. Just a way to unmute yourself if you want to talk or say something or participate in the conversation. Just either send a chat in the chat box, or right-click on your name and unmute yourself. And on the participants, just right-click and unmute yourself. I'd love to have the participation in the conversation here. That would be awesome. So. If you feel like you want to add something, I'd really appreciate that. Or if you have other questions, and I'm going to open it up at the end because we're not going to quite take an hour on this today, but I'm going to open it up at the end and ask if there are any other questions you guys have that you would like some opinions or feedback on. Do want to mention that if you are looking to get WQA certified, that starting tomorrow we have our live fundamentals course beginning. That's going to be 9:30 every Thursday, 9:30 Eastern for the next 8 or 9 weeks. And so if you're interested in getting your WQA certification and you're looking for a mentor, or you're just looking for somebody to help guide you through doing the modular education program online, then please let me know. I'd love to be able to help with that as well. If you haven't done the basics, which you have to do the fundamentals, then we can also help with that. So we actually have some previously recorded classes that you can hop on and watch, and that will help with your certification. First and foremost, as always, I want to say thank you. I really appreciate the opportunity to serve you guys in this way. It really is an honor. I appreciate very much you guys taking your time here. It's my goal, as always, to make sure that the information that I give to you is at least as valuable as the time you're giving to me. On behalf of Jen and myself and the Moti-Vitality team, we really appreciate very much you being here. So here we're going to start right off with this one. What's a dry well? This is a common one, and what you run into sometimes is a drain issue where you're draining it, and so different people have different codes. This is one of those things that I had heard about for a long time when I was out there in sales. What's a dry well? How do you do it? How do you dig a dry well? What's it for? Well, a dry well is an alternative for if you don't want to run the drain directly into a sump pump, for example. If you don't, of course, you could also run it into a sump and then have the sump pump drain into a dry well as well. But it's just a place to put a water softener drain. I found myself, when I first gone out into sales, I found myself having to dig a dry well myself for a customer, because I was down here in Michigan. We call them Michigan basements. I'm sure that everywhere else they're probably not called Michigan basements, but it was a basement. It was a dirt floor and had these old cast iron septic lines. There was no sump pump, and our installers had zero interest in breaking into the cast lines, and so it was either lose the sale or go out on a Saturday with a shovel and dig a dry well myself. So this is what I did. So this is how I learned what a dry well was. So basically, what I did here's, let me turn on my pen here so I can draw a couple things here. All right, so here's where the equipment was. This one shows the dry well going down underneath the house. That's not the way I did mine. Okay, so on mine, here was the equipment here, and we brought the drain line up. Usually, this area above the ground is wood because it sits on the cinder block, or there's some wood that you can go through up here. So the cinder block comes up above the ground level if there's a basement, and then there's wood on top of that where the house is, for a little bit. And that's what we did is we brought a drain. It was just PVC. We brought that down, and then we came down into the ground. Now you need to go down below the cross level, and I dug a trench all the way over. Your codes, your local drain codes are going to be different. The other thing that I did that was a little different on mine is I got a brine tank from the trash can that we had at the dumpster at the office. I just climbed in there and grabbed an old salt tank, an old brine tank, and I took a drill and I drilled bunches of holes through that brine tank, just like Swiss cheese all the way through there. And then I got some pea gravel. You can go down to the local church playground or school playground at night and back a truck up and get a bunch of pea gravel, or you could, I guess you could buy it if you wanted to. I mean, whatever, whatever your morals dictate. I mean, but however you're going to get the pea gravel, you take the pea gravel and you lay it down on the bottom of that hole. You got to dig a hole. All of this is dug out, right, in order to do this. So you dig a hole, you take that brine tank that has all those holes in it, or the trash can, you can use a trash can or whatever, and you put it upside down. So the mouth of it is down here, open on top of the pea gravel, the legally purchased and transported pea gravel. I guess I should probably suggest that. It is being recorded and all. So, but then I brought this, it was just 2-inch PVC, and I brought it down and I drilled a hole in top of this and had the water just drain straight down into that. So all that's hollow, okay? Put it in upside down, put pea gravel around the outsides of the thing, and then fill it all in. This line needs to be down below the frost line. The nice thing about doing a dry well is you're down below the vegetation line. Hopefully you've got a softener that's efficient enough. You need to make sure that your dry well is big enough to support all the water that's going to run out of that softener. If you have a softener that uses 75 gallons of water for regen, you probably need to have an area that's going to hold about 75 gallons of water, or pretty close, at least 50, so that it can slowly drain out of there and you don't get a backup coming into it. Obviously if you're going to have, this is not going to freeze and everything. So, it's down underneath. It's not gonna freeze there. But this area right here, since this is mostly salt water draining out, you're not going to probably have a problem since it's vertical. It's going to come out and it's going to go vertical, but you might want to run some insulation around it or something just in case. But this is a nice option. One thing that I have done, we ran into a lake one time where the water table was really, really high, and so I actually bought one of those Rubbermaid things, the long, closed things. It was long like this. And so I essentially did the dry well the same way. Instead of having to go down an extra 2 or 3 feet this way, I made this big long thing and did the dry well that way, to where it came in and just filled it up with pea gravel. So we've done that since then too. I'm not necessarily suggesting that you go out with a shovel and do this yourself, because that's kind of a pain. But I was a new guy and 20 years younger than I am right now, and didn't want to lose the sale. So You know, this is a common question, kind of a related question when it comes to drains. When I first came into business almost 19, 20 years ago, this was a big deal. You had septic system companies out there that were all telling your customers not to drain a water softener into the septic line because it would destroy the water softener. I mean, this was, sometimes you'd have, or I'm sorry, destroy, not to drain the water softener into the septic system. Sometimes it would, a septic system would go bad, and the septic system companies would kind of use the water softener draining into it as an excuse not to cover it under warranty or to repair it or that type of thing. You can always tell when you're looking at a new home. You're going to see two holes dug in the yard somewhere. You're going to see this somewhere outside of the house is going to be a big, huge hole that looks a lot like it's a swimming pool. It looks like they're digging out a swimming pool. It's going to be a really big one. By the way, I almost drove a car into one of these things one time. I pulled up into the house. I got as close as I could when I was out canvassing new construction. Pulled up in a yard, and it was raining, and it was muddy, and it was kind of on a slant, and I went to turn around, and the car kept sliding. It was like over, hang on, I'll show you. It was like I pulled it and pulled, it was slanted right here, the ground was along the way. I pulled my car around, and I kept sliding towards the edge. So one of the tires was, there's no way I was getting out of it. I couldn't back up. I could only go forward. And the homeowner, the buyer came, ended up in the rain, in the mud, slopping around the back, had to get a whole bunch of 2x4s and wood and stuff like that was laying in a pile out back, and put it on the corner of that thing so that I could drive over the corner without dropping my Oldsmobile Alero into their leach field before they put it back in. So stay clear of these things. But anyway, you'll see these big, when you go out to a new house, you'll see these big, it looks like a swimming pool. That's the absorption field. It basically, when the septic tank, so you're going to, somewhere in the yard, there's going to be usually a big concrete tank that's going to be buried. And it's actually not going to be that deep. You can usually tell in a yard when you get a really light snow, you look and see where there's a square somewhere in the yard, because the heat that comes off of this thing will come out through the ground, and that's the way that is at my house. Anyway, I've got a square, when there's like an inch of snow or whatever, the snow doesn't stick there or it melts there first. That's where I can tell I have the perfect outline of where my septic tank is. And then there's usually a clean out. They have to dig down into this thing to do it, to suck it out and clean it out when they come to clean out the septic system. But this is where all the sewage and everything in the house runs. And it looks like they got the clean out here on this one that sticks to the ground. Mine doesn't have that. You got to dig down and stick a thing in it. But anyway, you have when it overflows, it's going to seep out through here, and that's what all this stuff is. And so that it sort of filters it back out. This is usually way far away from your house and your well. This is one of the reasons, by the way, just on a different topic about whether softeners hurt septic systems, this is one of those things you got to be careful about if you have a really heavy truck or heavy equipment or something. You got to be very careful about driving a big truck through a yard, because you can crush those septic system lines for sure. So you got to be careful about that. So, but getting back to the question, do water softeners hurt septic systems? The cool thing about this was that, with the septic system companies all said, well, the salt water will kill the good bacteria and it makes it a real problem, and so on and so forth. And the cool thing about this is that now, because thanks to the Water Quality Association and the Water Quality Research Foundation, there is an actual study that addresses this very issue. environmental impact study. It's the executive summary. It is the water softener effects on septic system performance. So if you have some of those old school guys, the guys that are the septic system guys that are still out there saying that water softeners are going to hurt septic systems, the septic system industry and the Water Quality Association got together and they did this study together very objectively. And it's a really kind of interesting read that explains how the things work. Bottom line is this, that not only do water softeners, when they're set at efficiencies, not only do they help, or not only do they not hurt a septic system, but they will actually extend the life of a septic system. They actually help it last longer, help clean it out. So this is a really, if you have, of course, some of those people that have been doing it for years and years and years and years and years, they're, you just can't argue with them. We're going to get into whether it's worth arguing with some people here in a few minutes anyway, but you just can't argue with them. But it's there. And the reality is that a water softener, now when it's set at a high salt setting, it is going to hurt it. So if you've got really heavy iron, if you're max salt dosing that thing at 15, 16, 20 pounds or whatever, then yeah, that's not a good thing. But at an efficiency setting on the softener, when you're putting low levels of salt in there, when you have your softener set at efficiency ratings, it actually extends the life of the septic system. And we have it's a study that was done objectively by both industries and is completely factual, so it's kind of nice to have. Okay, so like I said, if you have any questions, let me know. But just to show you this, it's just one of the things it says. Study was undertaken to investigate the effect of home ion exchange water softeners that may have on the performance on on-site septic tanks. A laboratory study was set up with columns that contained solids collected from operating septic tanks. Wastewater was added with varying levels of sodium as well as calcium and magnesium, modeling the periodic addition of regenerant from softeners operating at different salt dosing ranging from high efficiency to very poor efficiency. To reinforce the column experience, data were obtained from private septic tanks to determine the effluent quality from septic tanks which did or did not receive regenerant from the softeners. The data indicate that the use of efficiently operated water softeners improves septic tank performance, while the use of very inefficient softeners may have a negative effect on solids discharged from the drain field. The level of impact will depend on the level of hardness in the water, whether the regeneration waste is discharged to the septic tank, and the amount of excess sodium present in the regeneration waste. So it's pretty clear. Okay, so going on to the next question here. That's a very long study. You can actually read the study. They break it down exactly what they did and how they did it and stuff like that, so it's pretty good. All right, so how about this one? We get this one all the time, right? Well, water softener takes out calcium and magnesium. I thought calcium and magnesium was good for me. Doesn't soften the water remove the good minerals like iron and calcium and magnesium? Why would I want to do that? Well, that is because when somebody asks that question, they don't really understand the differences between organic and inorganic. And so what we are getting in our water, the calcium that is in our water that comes right out of the ground, that is inorganic calcium. It's not going to hurt you any, but it's dissolved rock. It's like chewing on limestone. You're not going to get any real nutritional value from chewing. Same like with the iron. A railroad track is iron. If you go gnaw on a railroad track or a bunch of nails, that is inorganic iron. It's not the same kind of iron that you get from your asparagus or your red meats. It's not that kind of iron. Just like calcium is not the kind you get from milk or fruits and vegetables. Okay, so it's organic versus inorganic. And for those of you that are, I don't know, anybody recognize what this is from? I don't know what. This is the geek in me coming out with this picture is here. So because I was doing organic versus inorganic, and these are Organians from the original Star Trek. They had the treaty between the Klingons they forced the treaty between the Klingons and the Federation, the Organian peace treaty. Anybody with me on that? Okay. Anyway, moving on. It has nothing to do with the webinar, but it is kind of. Are there Iranian? Thank you, Jen. I don't even know how to pronounce that. Iranians. Anyway, moving on. So, can softened water be used for tropical fish? And so I was doing some research. Originally, I read the answer to this in the Water Quality Association textbook. This is where this question came from, and it was the answer is yeah, it can be. I mean, it's not going to, although it really depends on the fish. You know, there's a lot of things that will kill fish, and the pH of the water, and so ultimately it's best to go to your pet shop or somebody who knows how to do aquariums. But yeah, a lot of people use softened water, I think, for their fish tanks, and as long as the pH and all the other stuff is good, it's fine. RO water is better, but RO water is better because it gives you a baseline to start with. Okay, so you can re-add back whatever you need to make the water exactly what it needs to be. I put RO water in mine. I've got these 2 tetras in my fish tank that have lived. The things I can't believe. I don't know what the life expectancy of I've got this little 10-gallon tank. The life expectancy of tetras, I don't know what it is, but these things have lasted like 5 years, and I've even made the attempt. I mean, I've like tried to kill them, but I can tell you one thing that does also kill fish. If you live in a really cold climate, like in Michigan, and you leave for a week and you turn your thermostat down so the house doesn't freeze, but that the heat kicks on so it doesn't freeze, but it's still cold. You turn it down to say 50 degrees. Seems tropical fish don't like 50-degree water. So don't be surprised when you come home and you've got 8 little fishies floating on top of your fish tank. I mean, the good thing is you don't have to order out sushi that night, but they like warm water, so get a heater if you're going to do that. But RO water is usually better. RO water is better for them. It's clean, comes out. You don't have the chloramines or the chlorine or nitrates in there. All of those things. If you're going to add stuff back to the water, conditioner and that kind of stuff to the water, to the fish tank, then at least you're starting with a baseline. So, and man, as I was looking at this, it was really interesting to me. So when I was putting this presentation together, I was doing a quick Google search, and I asked that to see what other people said in all the forums. There's so much misinformation out there, you guys. It's really kind of incredible to me how many people, seriously, I was blown away by how wrong people were about how water softeners worked and what was happening in it. And they're speaking as if they're authorities. Like some of them actually work with with fish and stuff like that. And it's just incredible to me how much of a misunderstanding of the technologies that are out there is. I mean, sometime if you ever want to know what your customers are reading or thinking, we have an uphill battle to go out there and educate our customers. It's kind of eye-opening when you research some of this stuff. If you put yourself in the minds of just a regular Google searcher, somebody who's hopping on there and what they're going to read, and it's kind of interesting. It's worth doing too, just so that you have an idea of what your customers are running into. I mean, I wonder if they think that we're wrong, when we go in there. And I have to imagine that there are people in our industry, in fact, who also don't know, that don't have a clue. I just wish that we were, even people out there representing this industry, I wish that we all could be more educated and maybe combat some of the misinformation that's out there all over the internet and what people have, the way they think these things work. I must have had like the inner geek in me totally with me as I'm doing these PowerPoint presentations. I got a Star Trek picture. I thought this was a really cool humidifier. So at my humidifier at my house, I have soft water running to it, and I still have to clean out the filter. It's really dusty. It's a sodium on it. So when mine is hooked to my furnace, but I have had those little cabinet humidifiers, sort of like this, except not like R2D2. But even with softened water, you still have that sodium in the water, and the difference is that when there's hardness in the water, it's that, it's crusty and rocky and really hard and nasty. And with the sodium, you can sort of bang that filter off, and it gets pretty dusty, but you can reuse the filter quite a bit because the sodium is very soft. It comes right off of there. An RO run to a humidifier would be better, but you got to keep in mind a humidifier, especially when it's really dry, it can draw a lot of water out. You can run through a lot of water, and so there's a couple factors. If you have an RO, even if you have a big enough tank or RO water supply to supply the humidifier, it may not, because that humidifier is running, it may not meter the water production of it. You got to make sure that you have a softener that meters the water production of an RO, right? So there's some water softeners out there that are metered and they hook to an RO, but they have to set them up because the meter is not sensitive enough to meter the RO water. A lot of the better quality softeners out there will meter the RO production water, but if you've got an RO that's producing that's capable of doing 75 or 100 gallons a day, and that's what it's doing. It's constantly producing that water, but it's not metering that water usage through the softener. I mean, that's significant. You can run out of capacity with that softener. So, so I think most people probably just hook softened water up to a humidifier, which is fine. But you are still going to have some buildup on that filter. The filter is still going to have to be cleaned periodically because it is because of the sodium on there. So, okay. All right. All right. Yay, we got to do that twice. Okay, so does a water softener only take out hardness? This is something pretty cool, and if you ever go through the advanced courses on WQA, the MEP study, if you ever go through my courses, you'll learn this in a lot more detail, a lot more depth. But I want to this is a periodic table of the elements. Okay, so if you ever want to know if a water softener will take it out, something really cool is to simply look at this chart, because everything in a vertical line has similar chemical properties as anything else in that same vertical line. So, for example, we know we can regenerate a water softener with sodium, that's right here, Na, okay? We also know we can regenerate a water softener with potassium, that's K, right here. And the reason we can do that is because they're in the same vertical line, they have similar chemical properties. Okay, so actually that's why hydrogen is also in that same vertical line, which is why you can use acid or hydrogen to regenerate. That's actually what happens when you're using for deionization. You're regenerating the cation side with hydrogen, but you can also use anything else in this line, lithium or anything, to regenerate a water softener. Okay, so we know a water softener in general takes out calcium, right? We know it also takes out magnesium, which is hardness. So it stands to reason, if it's in the same vertical line, that it will also take out barium or strontium or radium, beryllium. It will take out anything in the same vertical line because they have very similar chemical properties. So some of this stuff is radioactive, and so it could even take out some radioactive particles. Anything in that vertical line. Typically speaking, by the way, and this is in general, things on the left side of the periodic table of the elements carry a positive electrical charge, and things on the right side typically carry a negative electrical charge. Okay, That's just something else to mention to you. I'm not going to get into this chart a whole lot, but when you go over here to iron, so here, this is manganese. It's a little more difficult to remove than iron. They're not in the same vertical line, but they are really close to each other on the periodic table of the elements. See that? So they're similar chemical properties because of that. Okay, both of those are transition metals as well, but it's kind of interesting. Okay, here's the fun one, and this is one I wish that the guy that I promised I was going to send the email to that I forgot to, that I mentioned earlier, this was a question that he had, so I definitely have to send this to him. But I know we get this all the time. So what's the deal with the alkalinity craze? Well, again, when you do a Google search and you look all over this stuff, you find there's so much on it. I mean, and I think you, just like a lot of the stuff, there's enough truth in it that you start to wonder, okay, is there any truth in this, or is this just a sales gimmick? I'm always suspicious when the bulk of the craze started from network marketing companies, and I'm not going to mention brand names, but there are a lot of these things are distributed through multi-level marketing, which you know, there's nothing. I mean, Tupperware is multi-level marketing. You know, Amway is and so product, just because something is marketed through multi-level, you know, or the pyramid type thing, that's where the focus gets to be more on getting your friends and family to buy into the product so that they can go out and start selling them, so that you get residuals off what they sell. I mean, there's all, you know, most people are familiar with the multi-level marketing concept, and sometimes, you know, Mary Kay is that way, and like I said, Tupperware. I mean, there are good products that are marketed out there under these multi-level marketing strategies. So just because it's done that way doesn't necessarily mean that it's not good. But I can tell you that what ends up happening is when you have a manufacturer of a product and they go out there and they market it through these multi-level marketing programs, you do tend to have a lot of misinformation and a lot of misleading information being spread out there pretty regularly. You know, these people, they go to a weekend rah-rah, woo, I'm going to get rich because I'm going to sell this and I'm going to save the world and I'm going to cure cancer and Alzheimer's and I'm going to make all this. And these are the claims, right? That drinking alkaline water is going to cure Alzheimer's and it's going to help you. It's going to help offset all the processed food that we eat. And our food is really super acidic, and this helps offset it and helps neutralize our blood and so on and so forth. When you actually delve into this stuff and read it, our bodies in general do a really good job of making acidic what needs to be acidic and making neutral what needs to be neutral. Our blood stays fairly neutral. Okay, our stomach acid is so acidic that it has to be in order to destroy and break down all the food and everything. So you know, the alkalinity claims, there's all kinds of claims out there. There's also a real misunderstanding when people think that alkalinity is strictly pH. I was watching a Facebook post that somebody shared, a Facebook Live video the other day, and it had something like 1.3 million views, and it was this lady, and she had all these bottles of water set up, lined up, you know, all these different brands of water that were out there, and she went right in saying, you want your water to be alkaline, you want it to be a high pH, and she had a little pH had like color chart and pH drops in each one of these little cups in front of these bottles of water. So they poured the water in there and it turned the color, and they were matching it up to these colors. And it was obviously the low mineral water like Aquafina, the reverse osmosis water, you know, or the purified waters and stuff like that. They all turned acidic, lower pH, and then the water that has spring waters and waters that that had extra minerals added to them, they all turned higher alkaline, higher pH. And there really wasn't any explanation, except she had her young daughter with her there helping her, and her daughter's like, ooh, this one's really bad. Oh, don't drink that one at all. You know, and she's talking about Aquafina and stuff like that. And I was kind of cringing watching this and almost jump into the comments, but then I thought, you know, sometimes it's just not, sometimes it's not worth jumping into a Facebook comment section, because you know, it's like it's like arguing with people at a health and fitness show when you go set up the booth and you have those people who read their brochure and they suddenly know more about water, and you know they that brochure and their multi-level marketing education equates to the PhD and the science studies that have been out there that are not bought and paid for by the companies that distribute alkalinity stuff. So here's my take on the alkalinity issue, because we do have customers out there that run into it. First off, there's no way I would spend $1,000 or $2,000 on a system that simply added mineral and raised the pH of my water. You can do that with drops. In general, this is what the way I have come to understand it. Okay, our bodies, we don't get our minerals from our water. We get that from our foods and stuff that we eat. Water is designed to help lubricate our bones and muscles and keep our, they help regulate temperature and stuff like that. Okay, but even if we needed it to be more alkaline, I can add on, just about every manufacturer out there has a mineral filter that you can put on as an extra filter that re-adds mineral back to the water and raises the pH. It is true that RO water has a lower pH. I mean, that's true. RO water does have a lower pH. It tends to be more acidic, and that is because you're taking out all the stuff in the water that would bind to hydrogen. Hydrogen's small enough to slip through the RO membrane. The more hydrogen there is, more free hydrogen there is in a solution, the more acidic, the lower on the pH scale it's going to be. Okay, hydrogen is the smallest element, so it will slip through that membrane. You're taking that stuff out, so it will lower the pH of that, because you're blocking all the stuff in the water that would that would bind up the hydrogen. Okay, so that is true. But so what? Start with a baseline. You know, flower shops often will start with pure water, and then they'll re-add back to the plants what the plants need to flourish, so that the plants don't have to filter out the stuff that's not good for them in order to get to the stuff that is good to them. So they take out everything. They start with a baseline. They take it all out, and then they re-add back to the water specifically what the what the plant needs. I kind of feel that way with RO water. I mean, it gives you that baseline. You're starting, you know what you're starting with. You don't have to, it's peace of mind. You know, so what if there are good things in the water? I mean, tap water may have some good things in it. You know, water coming directly out of a lake may have some nutrients in it that are good for you, but I don't want to have to worry about the one or two things in it that might not be good for me in order to get to those things that are good. So the cool thing with RO water is I start with the baseline. I start with a clean slate, and then I can re-add. And so here's my suggestion to you in terms of the alkalinity craze, okay? Don't compete with them. Don't see yourself as a competitor. Say, look, that's fine. If you want to add alkalinity to your water, then that's fine. Start with the baseline. This isn't a competition. It's a different product, okay? So my suggestion to you is avoid the controversy, avoid the argument with them. Begin with the baseline. And by the way, just as a side note here, when you do a Google search and you start looking at all of this stuff, some of the advantages they all say, I mean, taste is a big one. They say, oh, the water tastes so much better. People love the taste of alkaline water way better. Well, when you look at the top selling bottled waters, private label are like the generics, like the Great Value at Walmart, or which are all mostly reverse osmosis water, the purified water. It's almost all. Dasani is reverse osmosis water. they add a little bit of mineral back to it. You get about 40 TDS with this on it. Aquafina, reverse osmosis water with no mineral added back to it. Nestle, reverse osmosis water. Smart water is actually distilled water, which also is low TDS and acidic. It doesn't have, smart water is distilled. So, so when you look at the top selling brands of water that most people like out there, and you look at the top selling brands of water that people prefer because they like the taste or whatever, it's all reverse osmosis water. So, so when they're out there telling people that alkaline water or high TDS water is better and people prefer that and so on and so forth, that's not what the statistics say. That's not what people are buying. So don't necessarily buy into the brochure. You don't argue with them either, though. On the other hand, I will tell you, I have run across people. Don't assume that people are going to love the taste of RO water either, because there are an awful lot of people who are used to drinking spring water, and when they first taste RO water, they may not like it. Okay, and so don't assume that they're going to just go gaga over the taste of RO water, because taste is subjective, right? And just on another side note, this is the most recent WQA study that just came out, the consumer study. You guys have all heard me talk about this before, but look at this, just as just something to point out here. In 2017, 76% of the people out there are buying bottled water. 76%. Okay, and by the way, only 13% have water softener. So when you're setting up a fair booth or something and you see all the people walking by, okay, almost 8 out of 10 of them are buying bottled water, and well, let's say even 2 out of 10 are buying water softeners. What are you marketing to? What are you selling? Okay, so fluoride. I had an opportunity last year to go down to Wellington, Florida, and sit in a debate about whether they were going to put fluoride back in the water. So they had taken it out a few years ago, and they wanted to put it back in, and they had the sides separated. On one side was the anti-fluoride side, and the other side was the pro-fluoride side. This was amazing. Now, just so you know, I actually am anti-fluoridation, but I'm not anti-fluoridation because that I don't think it works. I'm anti-fluoridation because the fluoride is on the EPA's maximum contaminant level. It is at high levels, at over 4 parts per million, it causes osteoporosis, and it gives you brittle bones and stuff like that. On the other hand, low levels of fluoride, this is the American Dental Association supports fluoridation. It says the American Dental Association unreservedly endorses the fluoridation of community water supplies as safe, effective, and necessary in preventing tooth decay. This support has been the association's position since the policy was first adopted in 1950. So when I went down there to Wellington, it was so interesting. So I'm sitting there on the anti-fluoridation side. My reasoning for anti-fluoridation is because I personally, this is only a personal opinion, not endorsed by anybody but Kelly Thompson, okay? It's that I'm not a big fan of trusting the government to regulate how much fluoride is put in and out. I would rather, again, kind of have that control myself. Municipalities are a government entity, and sometimes they mess up, and so I think sometimes I prefer, when it comes to my drinking water, for me and my family, I prefer to have the peace of mind and have that in control, so I can do fluoride drops or that ACT mouthwash. I'm also 47 years old and have never had a single cavity in my life, and I've drank RO water for 20 years, so almost exclusively RO water for the last 20 years. So everybody tells me that I'm pretty lucky to have never had a cavity, but I have good teeth, I guess. But anyway, I was sitting down there and listening. I swear, this is one of the things that somebody said. Okay, they said that one of the components of Prozac is fluoride, and so the government is putting fluoride in our drinking water to help subdue its citizens so that they can come take away all of our guns. I swear, this is somebody, a grown person, stood up and said this in front of the city council. And there was, I mean, it was conspiracy theory after conspiracy theory, and they threw in the anti-vaccines and the 9/11 was an inside job. I mean, I was sitting in a room full of absolute conspiracy theorists, and just feeling a little like, I mean, embarrassed a little that I was on the anti-fluoride side, because my reasoning didn't sound so wacko to me. Then on the fluoridation side, you had, doctors and scientists and dentists and all these reasonable, well-spoken, showered people, and they were, I mean, of course, the City Council of Wellington unanimously voted to add fluoride back to the water. But it was just really interesting. So my point with all of that is, it's okay. Like I said, I'm anti-fluoridation. I would rather, if I was on city water, I would absolutely want to take the fluoride out of my water and start with that baseline. I don't like, I mean, I understand the value of adding things in the water like chlorine and, I mean, since we added chlorine to the water, death and illness from microbiological contamination has dropped down to nil. Tooth decay, all the records, all the evidence, all the science shows that since we added fluoride to water, tooth decay has dropped dramatically in the country. So, I mean, there's a lot of evidence out there to support it, but I myself, I like, when it comes to the drinking water, I like to know what I'm consuming there. I don't, everybody knows about chlorine, but what they don't, on the city water, but they don't know about all the polyphosphates and the sequestering agents. And I mean, that's what happened with Flint. Somewhere up, even the officials thought that it was just chlorine that was the issue. I mean, that whole Flint, Michigan thing started with Legionella. There was Legionella, so they super chlorinated it. They put the chlorine in there, and that ate up the coating, the sequestering coating. The reason you don't have the Detroit water is running through those same pipe systems. The reason people weren't getting lead poisoning with Detroit water is because Detroit they add sequestering agents to the water that coated the pipes and kept the lead from all these old pipes from leaching out. So it makes you wonder what all chemicals are those municipalities adding to the water. I mean, there's tons and tons and tons of them. I don't even know what they are. And so I like starting with peace of mind. I like starting with knowing exactly what's in there. Bottom line with this, though, is don't get into an argument. I mean, it's not your story, right? The customer, they either want the fluoride in the water or they don't want it in the water. If they don't want it in the water, we have a solution for that. We can take the fluoride out of the water with the reverse osmosis. Okay, so it's their story, not yours. Don't, I would send them to their dentist or have them do their own research on it. And if they decide they want to take the fluoride out, then they can do it. This is strictly from Water Quality Association. I mean, children under 9 years of age exposed to levels of fluoride greater than 2 parts per million may develop a condition known as mottling or discoloration of the permanent teeth. Exposure to drinking water levels above 4 parts per million for many years may result in cases of crippling skeletal fluorosis, which is a serious bone disorder resembling osteoporosis and characterized by extreme density and hardness and abnormal fragility of the bones, sometimes called marble bones. I don't want a municipality putting that in my water. I want to take it out. That's just my personal opinion. All right, so here's one. Does an RO waste water? I hear this all the time too, and I'm not going to get into the long details of this, but I will tell you, when you have a customer that asks about this, let's put it in perspective. First off, this is still, when I came in the industry almost 20 years ago, and some of you have been doing this longer than me, I know, but you'll remember, I mean, reverse osmosis technology has dramatically improved in the last couple decades. it was not uncommon to see a 10 or 20 to 1 ratio on some reverse osmosis systems out there. Those membranes, they were, you know, it was, they were just very inefficient. But when you compare it today, there are a lot of reverse osmosis systems out there that are 1 to 1 or 2 to 1. And what I mean by that, and if you don't understand how reverse osmosis works, that's another class, another time. Give me a call, I can explain to you how actually this works. But I'm going to assume everybody understands how a reverse osmosis works. I mean, it takes a couple gallons, at least 1 gallon, to produce 1 gallon of pure water, or, you know, the purified or high quality water. But let's say you have a family of 4. The average family of 4 is going to use about 2 gallons a day total for drinking and cooking. That's coffee, tea, Kool-Aid, ice, water, all of that stuff, roughly about 2 gallons a day. Okay, so even if you have a reverse osmosis system that uses, let's say it's a really, and this would be considered a really inefficient reverse osmosis system today, let's say it's a 5 to 1. A 5 to 1. That means that for every 1 gallon of high quality reverse osmosis water it makes, it throws away 5 gallons. This, by today's standards, would be an extremely inefficient reverse osmosis. But in that instance, you're going to throw away 10 gallons of water a day. Okay, let's look at some of the other stuff, right? So conventional toilet is going to use, let's go with the efficient ones. The efficient ones, okay, not even the, because most of the toilets nowadays are efficient. They have more efficient flushes. So 1.5 to 3.5 gallons per flush. Multiply that by 10 people in the house, or 10 people. It's like the Octomom's family. Multiply that by 4 people in the house, each going to the bathroom, let's say, you know, 3 times a day, right? So let's say 1.5. So now you've got 4.5 gallons of water per person in that house. So that's roughly, what, 18 gallons just from a toilet flush within a family of 4. Twice as much as a reverse osmosis. A shower, let's go with the conservative. Let's assume they have a flow restrictor on their shower head at 2 to 4 gallons per minute. Okay, let's say it's 2 gallons a minute. It's a 10-minute shower. That's 20 gallons, literally down the drain. A bath, 30 to 40 gallons is what they're using there, you know, to fill that bathtub. Laundry, an efficient washing machine is going to be 42 gallons. Dishwasher, 7.5 gallons. Dishwashing by hand or letting the water running, 10 to 20 gallons. Shaving, 2 to 5 gallons. Brushing teeth, 2 to 5 gallons. Washing hands. When you compare it to other water-using appliances, you suddenly realize that the reverse osmosis system is one of the most efficient water-using appliances in the house. And let's compare it to its importance. I would put high-quality drinking water or peace of mind in my drinking water, I would put it right up there with my toilet flushing or my brushing my teeth or any of these things. I would put it up there as high priority. All right, should I water my grass with soft water? Probably not. It's not going to hurt it so much on the outside. You're going to waste regenerate. There's not really a whole lot of reason to do it. If you've got iron that you don't want staining your landscaping up, there are other options that don't use a regenerate. You know, of course, there's some that use a chemical like polyphosphates or whatever, but no, you probably shouldn't water your grass. The sodium is certainly not going to be good for your plants. If you use potassium chloride, that's actually not going to hurt your lawn, but your potassium is what, $30 a bag now, so you're going to blow through that stuff like crazy. So if you're really rich and you're trying to just throw money away, then yeah, you could use that, but probably not. You don't want to use that. You definitely should not do your inside plants. And here's the difference. Outside, you get enough water runoff from the rain and stuff like that that it sort of dilutes the sodium as it seeps down in the soil. You get enough runoff. Your inside plants don't. The sodium gets trapped in the soil, and your plants are going to really struggle. They're going to have a hard time with it. So again, for my flowers and inside plants, I always use RO water to water them. But I also use fertilizer. So I sprinkle a little tomato food on them or whatever, and use Miracle Grow and to help fertilize that soil with the nutrients, but I water them with RO water. Is sodium in the water bad for you? Well, this is kind of an interesting, we get that a lot, right? So first off, my answer to that is I'm not a doctor. I'm not a doctor. I don't play a doctor on TV. I haven't even watched ER in a long time. I mean, I used to, but I don't even, not anymore, because it's not on anymore, and there's, so why watch old reruns? There's lots of stuff on now, like Game of Thrones. Game of Thrones, which really doesn't have any doctors, but they could use some on that show, that's for sure. Anyway, I told you, inner geek coming out of me, but it's a good show though. Anyway, this is just a nice little chart that tells you how much sodium. So if you're starting with your initial water hardness, let's say it's typical city water around 10 grains, then per quart you get about 75 milligrams per quart of sodium added to the water. Let's just look at a couple examples of how that compares to some of our foods. This is a can of Campbell's soup. Looking here at the total sodium per serving, by the way. Okay, a serving size is half a cup, and there are 2.5 serving size in this tiny little can. Sodium, 480 milligrams of sodium in there. So multiply that. If you ate this whole can of soup, then you've got, I don't know, 1,300 milligrams of, 1,400 milligrams close to of sodium in there. I guess I'm doing my math wrong. 1,200 roughly of sodium. That's a lot, more than the water you're drinking from your softened water. Of course, if you put an RO in, no problem. It takes the sodium back out. These are green beans. Jen asked me to put this on there just in comparison. So just green beans. Oh, we're going to eat healthy. We're going to eat vegetables. It's going to be good. This one, the no salt added one, does have sodium, only 10 milligrams. So that's good. You don't have a lot of sodium in that one. But look at this, just a regular organic. Organic's got to be healthy, right? Oh, that's totally good. 390 milligrams of sodium. How does that compare with your soft water? Same thing with this one, the Del Monte, 90 milligrams. Interesting. This is corn. Corn is healthy, right? And corn, how can that be bad? 300 milligrams. Oh, but look at the serving size. That's 300 milligrams times, so what? 1,150 milligrams of sodium if you ate this whole can of corn. Pretty amazing. I don't know if you guys love corn that much, but I like corn. So anyway, all right. Questions or comments on this? Questions or comments? I'm unmuting everybody here, so I think I unmuted everybody. Maybe I just unmute all. There, everybody's unmuted. So what do you guys think? Comments, questions, anything?
Hi, Kelly. This is Jose. Can you hear me?
I can, Jose. How are you?
Very good, thank you. Great presentation here. Wanted to ask you, and I jumped in very late. I'm sorry for that, but I'm assuming you didn't touch base on this matter of 1,4-dioxane, which is a very popular, contaminant, emerging contaminant, and it seems that RO cannot remove it. I'm just wondering if maybe, being that we're talking about contaminants in general, if there's any customer that may have come across, to you asking about it and see what solutions you may have.
Yeah, I think you and I were talking about that before. So is it that RO will not take it out, or that it's not certified to take it out? Because that is one of the limitations to RO right now, is that, when we had that spill in, over in Virginia, in the river there, and when we've had, there's been lots of spills where there's so many chemicals that we create on a daily basis out there by the pharmaceuticals or the industrial manufacturing facilities that you can't test them and regulate them fast enough, and you can't test to see if reverse osmosis will, they're not certified for it. I know that you and I kind of briefly talked about all that before, so it's not a matter of, it's whether the RO is certified for it, right?
Yeah, no, actually, it seems to be related to the fact that only so far advanced oxidation seems to be removing it because it breaks it down and then the GAC can remove it. But the actual process of reverse osmosis can't because it's actually so soluble that it'll go with the molecules of the water as well.
Yeah,
But I was wondering if maybe distillation may be an option, you know?
Yeah, I'm not real familiar with that on that particular contaminant on this one. So, but
All right, just figured it out.
That's the kind of stuff that makes the industry really interesting, though. I love those new challenges. What you guys have any other common ones that customers ask, or any thoughts or comments? Okay, as always, you guys, I'm going to upload this to the website. It will be on there. You'll be able to review it, and I watch for next month's. We're going to try and gear that one towards owners and managers like we try and do. I appreciate any feedback that you have. Please, if you have any feedback or comments or thoughts on this, there is a survey on the website that you can fill out and let me know how you think I did, or just shoot me an email. I always appreciate the comments and thoughts on this. Thanks, everybody. Be safe. Have a great day, and I will talk to you.
Thank you.